so. Yeah. So yesterday we completed with this part. Have a look at this. This was the last part we did yesterday: evolution and uh, absorption of heat. That is exo and endothermic, right? If I'm not wrong. And then today we have to do the catalytic reactions. Now, catalytic reactions are those which are particularly very slow. Okay, they are very slow reactions. So what we need to do is we need to enhance the speed of these reactions. And how do we enhance the speed of these reactions? By using catalyst. Now, what is a catalyst? A catalyst is a compound which is, yes, tell me, catalyst is a compound which is not consumed in the reaction. Okay, it is not consumed in the reaction, but it increases the speed of the reaction. Not consumed meaning what? See, if I add iron over here, so iron interacts, the nitrogen and hydrogen will interact on the surface of iron. But if I have added 5 kg of iron in the beginning, at the end of the reaction also I'll get back 5 kg. So my iron is not getting consumed, right? The iron which we have used is not getting consumed. What is happening? The iron is not getting consumed. What is happening instead? जी बताइए. It is only allowing the reactants to interact on its surface and increasing the speed of reaction. Okay, so for example, catalyst used over here is iron, and to activate the iron, to increase the activity of iron, we use a promoter called as molybdenum. So what is a promoter? Promoter is the one which increases the activity of a catalyst. Promoter is the one which will increase the activity of the catalyst. On the other hand, poison is the one which will decrease the activity of catalyst. Now, when do we want the activity of the catalyst to decrease? If the catalyst is, converting the, if it is proactive and it is converting the reactant into the products which we are not desired. Like, let me just tell you this. Okay, like, say for example, we are traveling from Pune to Mumbai. Okay, we are traveling from Pune to Mumbai. Okay, and I want to get down at Lonavala. But if the train is a bullet train, okay, if the train is a bullet train, it will not stop at Lonavala. It will directly stop at Mumbai. But I don't want to go to Mumbai. I want to get down at Lonavala. So at that time, I will not board a bullet train. Okay, I'll have to board a normal train which will stop at Lonavala, because my destination, my desire is not to reach to Mumbai, but to reach to Lonavala. If I want to reach to Mumbai, no problem. Sit in the bullet train. It will directly take you. Similarly, if the catalyst is proactive, like it's a bullet train, right, it will take you directly to the final product. But I don't want the final product. I want the intermediate product. And when I want the intermediate product, then I use, in that case, I decrease the activity of the catalyst. And how do I decrease the activity of the catalyst? By poisoning the catalyst, right? Poison is the one which deactivates the catalyst or decreases the activity of catalyst. Poison is the one which decreases the activity of catalyst. So you can see over here, 2SO2 gives 2SO2 plus O2 gives 2SO3. Vanadium pentoxide is the catalyst which is used, yeah, to convert SO2 into S2, right? So these are the catalyst. This is the catalyst, and you also have understood the difference between poison and promoter. Promoter is the one which activates the catalyst. Poison is the one which deactivates the catalyst. Are you getting this?
Yes, sir.
Yeah. So now let's move on to the next part, that is activity series of metals. Now, in this activity series of metals, you very well know that the metals which are placed on the top are the most active metals, and the metals which are placed at the bottom are the least active metals. So you can say that the metal activity decreases as you move down the group. And I've told you, I've given you a mnemonic in order to remember these metals. And what is the mnemonic? The mnemonic is Kabir ne Canada में अपने जिंदा दिल फ्रेंड परब को 100 कैरेट हीरे सिल्वर gold and add one more platinum diya. Okay, so what am I supposed to add? I'm supposed to add one more element, that is one more metal, that's platinum. And how do I remember it? With the help of Kabir, I remember K is potassium, Ne With the help of N, I remember Na, that's natrium or sodium. Kabir ne Canada, with the help of Canada, I remember calcium. May, I remember magnesium. Apne aluminium. Okay, apne aluminium. Zinda dil. Okay, Zinda dil friend. Zinda dil friend. Parab. Friend ferrum. Parab plumbium. Parab co 100 hydrogen. Carrot copper. Hire Hg. Silver gold. Silver is argentum. All of you know that. Gold Oranum. That's why AU. Silver, gold, platinum, Dia. Okay, so this is how I remember the entire metal activity series. Kabir ne kya tha मेरा friend. Parab ko 100 carat हीरे, gold, silver, gold, platinum, Dia. So with the help of this mnemonic, you can remember the entire activity series. You can remember the entire activity series. Are you getting this?
Yes, sir.
Yeah. So this is your metal activity series. The obviously why I'm showing you this, because I want to show you that the metals placed above are able to displace the metals which are placed below. Now, for example, say for example, we can take calcium. Calcium can displace hydrogen. See how? I'll show you in this reaction. Calcium, or let me write over here. This is a blue background, so I think it will be seen better. Or let me just take the note. Okay, so yeah, calcium plus H2SO4. So you can see over there in the activity series that calcium is placed way above hydrogen. So calcium will be definitely be able to displace hydrogen, and you will get calcium sulfate. So calcium is displacing hydrogen. That's why you are getting hydrogen gas. What are you getting? Hydrogen gas. Calcium sulfate plus hydrogen gas. So what happened over here? Calcium displaced hydrogen and combined with sulfate to form calcium sulfate. And here you get what? Hydrogen gas. Here you get what? Hydrogen gas. So calcium plus H2SO4 gives a CSO4 plus H2. Calcium sulfate plus hydrogen gas. So any other metal, if you want to do this example, say for example, we are having sodium with AgNO3. So what will sodium do? Sodium will displace silver. Sodium is right on the top, silver is right at the bottom of the activity series, and therefore it will be easily able to displace, and you will get NaNO3, sorry, NaNO3 plus Ag. So whom is sodium displacing? Sodium is displacing silver. Yeah, sodium is displacing silver. Yeah, are you understanding this? Sodium is displacing silver, and therefore you're
Yes,
getting
sir.
what? NaNO3 plus H. Are you understanding this, each one of you? Hello.
Yes, sir.
Yes, sir.
Yeah. So this is your reaction. Okay, displacement, and the metals placed on the top are able to displace the metals placed below in the activity series. Now, remember, all metals can displace, all metals above hydrogen can displace hydrogen from an acid, except for lead. Okay, lead cannot displace. Okay, lead cannot displace hydrogen. Just remember that lead cannot displace hydrogen, although it is above hydrogen, because it's just above hydrogen. It cannot displace, it's not having that much power to displace hydrogen from an acid. Okay, but all, and of course copper also, the metals below to sawali nahi, they will not be able to displace the hydrogen. Okay, so this is your activity series of what? Metals, right? Activity series of metals. I hope you are understanding.
Yes, sir.
Yeah, so here we are having conditions for chemical changes. Now, for a chemical reaction to be brought about, what needs to happen is there should be certain chemical changes, certain factors to bring about those chemical changes. So So let us see what kind of factors are required for a chemical change to be brought about. That means chemical reaction to take place, it requires certain factors. Let's see what are they. Okay, first thing is by close contact. You can't say that, okay, I want to react zinc and iron and I'll react by Wi-Fi. No, that's not possible. So if you want to react zinc and iron, they need to be in close contact with each other, close physical contact with each other. They should bombard on each other, then only they will be able to react. Otherwise, there is no reaction possible. Okay, so without close physical contact, there cannot be any chemical reaction. Okay, we haven't yet devised a technology which could react if you are having a reactant A in Pune, reactant B in Mumbai, and they are reacting with each other. Till now, we have not devised such a technology, right? So for a reaction to take place, you need to have the reactants, the two reactants, in close physical contact with each other. Unless and until that is happening, the reaction is not going to take place. Okay, then it will be better if they are in contact in solution. Right now, say for example, I have. Let me show you this. For example, that I have, say for example, this is a reactant A, and this is the reactant B. Right, this is reactant A and reactant B. Now I've kept them in close contact. Are they reacting? Is this reacting with this?
No, sir.
No. Okay. So when will this react with this? When there is sufficient amount of bombardment with that kind of intensity, when there is a lot of bombardment on each other, then they will react. But even when they react after bombardment, they are in the solid state. You can see this. This is the solid state, right? In solid state, what happens? Now, in solid state, what's going to happen? The surface molecules of this solid and the surface molecules of this solid, only they will interact. The other molecules which are present on the other side, okay, only this side was reacting. What about the molecules on this side? What about the molecules inside? They are not coming in contact. And because they are not coming in contact, they are not reacting. So it will be better if this solid is dissolved in a liquid. Okay, it will be better if this solid is dissolved in a liquid. And when it is dissolved in a liquid, what will happen? Yes, ladies and gentlemen, when it is dissolved in a liquid, what is going to happen? All the molecules will get a chance to interact with each other, right? And the bombardment will be at a greater level, greater extent, and therefore the reaction will take place much more easily. Okay, then contact and solution. Then by supplementing energy, yeah, as I told you now, chalo ek मान के चलते कि ये दोनों को we have dissolved in a particular solvent. We have now these both are in solution. They are not solid anymore. They are in solution. But how will you make them bombard on each other? How will you make them collide with each other? And those collisions should be fruitful collisions, right? So how will you make sure that they are fruitful collisions? So that can be done, ladies and gentlemen. That can be done by ensuring that you're supplying enough amount of energy, right? Enough amount of energy. So when you supply energy, let that be kinetic energy, or you can increase the pressure, or you can use a catalyst, or it can be any form of energy, right? So when you supply energy, what's going to happen? Their kinetic energy will increase and they will give you fruitful collisions. Okay, so that is going to happen when you supply energy. So there are different ways, not only temperature and pressure, there is heat. There are some reactions which are accelerated or they are initiated when you heat them. Okay, many reactions. So mixed lead oxide will give you lead oxide plus oxygen only after heating. So this is a decomposition reaction which will take place only after heating. Okay, then if I have light, okay, so light can accelerate this reaction H2 plus Cl2. So what will light do? It will break bonds of Cl2, it will break bonds of H2 and allow them to collide with each other and react with each other to form HCl. Okay, then electricity, for some reactions we do require something called as electricity in order to carry out the chemical reaction. So we are supplying energy, maybe in the form of heat, maybe in the form of light, maybe in the form of electricity. For what? So that the molecules, remember that they should be in close contact and they should be colliding with each other. Then only we are going to get what? Then only we are going to get the product. Then pressure, like in N2 plus 3H2 plus 2NH3, we need to apply a lot of pressure. Then only the reaction will move in the forward direction. Otherwise, 2NH3 will decompose to form N2 plus 3H2. Right? It will decompose to form N2 plus 3H2. Then catalyst in catalyst we are having 4NH3 plus 5O2 in platinum. In presence of platinum will on its surface it will accommodate ammonia and oxygen and then convert it to nitric oxide. So I told you sometimes you have to what does catalyst do? Catalyst lowers their energy, activation energy. So what is activation energy? Activation energy is the amount of energy which we need to supply to the reactants so that they interact with each other, so that they collide with each other, so that they start reacting with each other. That is called as activation energy. But when you use a catalyst, this activation energy is decreased. Okay, this activation energy is decreased. So molecules can interact with each other with a lower energy if you are using a catalyst. And there are a few reactions which are carried out by sound energy. See, sound is also a form of energy. So we can use ultrasonic waves or infrasonic waves, whichever form of sound waves, in order to carry out some reactions. So energy can be supplied, okay, in any form it can be supplied in order to make sure that the reactions do react with each other, and that can happen only after fruitful collisions take place. Yeah. Hello. Are you getting this, or is this going bouncers to you? Hello.
Yes, sir.
Yes,
Are you able
sir.
to understand this? Yes.
Yes, sir.
Do we have Janice? Do we have Janice in the meeting? Janice, are you
Yes,
here?
sir.
Are you understanding?
Yes, sir.
Yeah. Atharva, are you understanding? Atharva, Bela, Harshita. Then do we have Nisi? Nisi is there today? Nisi is absent today. Please ask Nisi. Okay, please ask Nisi to watch the recording. I'll send the recording. Please ask her. Okay, and so that she does not miss out. Okay, now let's do a short recap of whatever we have done. Go through your entire this chapter, chemical reactions, and if there are any questions, please ask. Just go through whatever we have done up till now. Right, recap it, and if there are any questions, please go ahead and ask. Then what I'll do is I'll change this mic, because when there is any kind of traffic, you are able to hear it. But if I use a noise filtering mic, I think it will be better for you. Yeah, are you going through the chapter? Do you have any questions?
No, sir.
No, sir.
Yeah, should I move ahead?
Yes, sir.
Yeah, so I think this is a better experience, better sound, no background noise. Yeah,
Yes.
okay. So also y'all, yeah, what you can do is take these equations, right? This is your homework. What are you going to do? You have to write word equations for this. This is like potassium chlorate, and also you have to balance these chemical equations. So 2 moles of potassium chlorate will give you 2 KCl plus 3 O2. Okay, so potassium chlorate plus potassium gives you potassium chloride plus oxygen. So word equations you'll have to write. And yesterday we had decided to do your practical chemistry ki kuch equations. So once you finish with this, yeah, once you quickly finish with this, we have time. We will do your equations from practical chemistry as well. Okay. Yeah, you all have done this, I know, but okay, fine. Then we'll quickly move on. The children who are new can take a screenshot of this and do it as homework. And let's now move on to the equations of practical chemistry.
Yes, sir.
Yeah.
Yeah.
Yes. Can you send me a picture on WhatsApp? Picture of your practical chemistry. 2 pages are only there, right? Send me a good quality, clear picture. Okay, don't click from WhatsApp camera. Bela, can you do the needful? Don't click on the WhatsApp camera. Click with your normal camera and send it to me. We will display it out over here on the screen.
Sir, I think we have done this already.
Yes, then I've told Bela to send a pic of uh, practical chemistry equations. I'll be displaying on the board and we'll be doing the same.
Okay, sir.
Yeah, and those children who have not done this earlier, they can take a screenshot of this and solve it later for homework. Okay, where were you when I was saying all this? Where were you?
No, sir, I was there, but your voice was little breaking for me because the internet is not stable here.
Okay, what's your name?
Sir Sahil.
Sahil. Sahil, you were there yesterday as well?
Yes, sir, I was there yesterday.
What is your surname, Sahil? Because we are having two Sahils.
Yes, sir, I'm Sahil Katkare.
Okay. Sahil Gaure is understanding. Sahil Gaure. Are you there in the meeting, Sahil?
Yes, sir, he is there.
Yes, let him unmute. Yes, Sahil, are you here? Probably he's just there, not present here mentally and physically. Yeah. Bela, have you sent me? Bela, are you there?
Sir, she is not there in the meeting.
Okay. Then can anybody else send it quickly? You can send it on the group as well. Take two clean pictures of uh, the practical chemistry 2 pages, and then I'll put it up on the screen. Yes. Are you waiting for each other to send? Please don't waste time. Hurry up. Who's sending it? Atharva, are you sending it?
So I'm sending it.
Yeah, hurry up.
Sir, I sent you.
Okay, thank you. Yes, this is the thing. Hello,
Yes,
can you
sir.
hear me? Yeah.
Yes, sir.
So this is your textbook. Then we are having neutral gases. Neutral gases is water vapor. Water vapor is obviously colorless and odorless, and as it is neutral, it's as it is a neutral gas, is neutral to litmus as well. Okay. Then copper sulfate plus 5H2O gives you copper sulfate dot 5H2O, right? So you can see water vapor is interacting, and this is how we can detect it, right? So white copper sulfate will turn into blue if you interact with water vapor. Then cobalt chloride will turn into pink when it interacts with water. That's how you can detect that yes, it is water vapor. Okay. Then hydrogen is also neutral gas. Okay, don't think that hydrogen H plus ion, so we will have uh, you can call it as an acidic gas. No, it's a neutral gas, and it's colorless, odorless again. And now it burns with a pale blue flame, and it burns with a pop sound. That is the test, you can say. And burning wood splinter is extinguished in uh, hydrogen. What is a burning wood splinter? Agarbatti. Agarbatti is called as a burning wood splinter, and it will get extinguished in what? Atmosphere of hydrogen. Then oxygen, it's a supporter of combustion, it's colorless, odorless, again neutral to litmus. Then it rekindles a glowing splinter, right? Agarbatti ko rakho, it will burst into flames in oxygen environment. Okay. Then absorbed in colorless alkaline pyrogalol. Pyrogalol absorbs your oxygen. Okay. Then talking about the acidic gases. Acidic gases are carbon dioxide. When treated with water, they will give you carbonic acid or calcium bicarbonate, which is acidic. Then calcium hydroxide plus CO2 will give you calcium carbonate, which is white PPT. This is the test. And why is it acidic? Because on treatment with water, it will give you carbonic acid. Okay. So here we'll be having like CO2 plus H2O will give us H2CO3. Okay, H2CO3, carbonic acid. So this is acidic. That's why carbon dioxide is an acidic gas. Carbon dioxide is what? It is an acidic gas. Then sulfur dioxide. Sulfur dioxide is also an acidic gas. Its odor is suffocating, and test for carbon dioxide will be, you've seen that lime water turns milky. Lime water will turn milky. Then sulfur dioxide ke liye also lime water turns milky. And another way to distinguish from carbon dioxide is the orange colored orange colored K2Cr27 turns into green. So that is the way we can distinguish sulfur dioxide from carbon dioxide. Okay. Odor of carbon dioxide is it is generally odorless, but sometimes it may feel a little pungent. Okay. Then acidic gases. Chlorine is an acidic gas. Right. I hope you are able to see this. Chlorine is an acidic gas. It's a greenish yellow color gas, and moist blue litmus turns red. That means chlorine is acidic. Odor is pungent. Chlorine plus H2 will give you HCl plus HOCl. Okay, and then chlorine plus 2Ki gives you KCl plus I2. I2 is blue in color, right? So here we can identify the chlorine gas. Then hydrogen chloride, it's acidic, so it will turn moist blue litmus red, and odor is pungent, colorless. Okay. Then ammonia plus HCl, this will give you dense white fumes, hence you can understand that HCl is there. With AgNO3, it will give you white precipitate of AgCl, hence you can understand that HCl was present. Then hydrogen sulfide gas. Now hydrogen sulfide gas has the smell of rotten egg, the most easiest to identify smell of rotten egg, and this smell of rotten egg will I mean, it's not only an identification, but it is also hazardous. You should not, uh, you know, allow this H2S gas to be inhaled for a longer extent. Otherwise, it is hazardous. And how do you identify this? It will decolorize the KMNO4 solution. Pink KMNO4 solution will turn to, pink KMNO4 solution will turn to colorless. So that's how you identify H2S gas. The nitrogen dioxide, again very easy to identify. It's reddish brown in color, and its odor is irritating, right? So when you treat it with Ki, again it gives you I2. I2 is having a blue color itself, and it also turns your potassium iodide paper to what is that written? to brown. Yeah, it turns the starch iodide paper to brown. Okay, then basic gases like ammonia is a basic gas. Again, it can be identified by treating it with HCl because it will give you dense white fumes of NH4Cl. Hence, it's easy to identify NH3 as well. Its odor is pungent, it's colorless, right? With copper sulfate, it will give you ammonium sulfate and copper hydroxide, which is blue in color. That's another way to identify your uh, ammonia gas. Okay. Then we are having copper carbonate. Copper carbonate will decompose. Okay, action of heat we are seeing. Copper carbonate decomposes to form copper oxide and carbon dioxide. Okay, and what is the observation? Observation is obviously gas evolved as carbon dioxide, and this will turn lime water milky. So that can be an observation. And original color of this copper carbonate is light green to black. That is the main thing. How we can identify this change in color? We can identify the change in color or the observation as you can shade this with light green. Let me check if I can do it here. Yeah, I can shade it with light green. Yeah. So I can shade it with light green. This light green color you will remember. And this is forming what? Black colored. This copper oxide will be black in color. Okay, copper oxide black in color. So that's how you remember that light green is turning into black. Okay, this is what I meant yesterday when I asked you to do the mark with color pencil. Then zinc carbonate is white in color and it will convert into zinc oxide because zinc oxide it's a decomposition reaction, simple decomposition reaction in which we are converting it into ZNO plus CO2. And we also know that zinc oxide is yellow when hot and white when cold. Zinc oxide yellow when hot, white when cold. Right. In this chapter, do we also have the decomposition reaction and all that? Yeah. Do you have the decomposition reaction?
No, sir.
No. Okay. So it will split into ZNO plus CO2. This is an example of decomposition reaction. What do you mean by decomposition reaction? Decomposition reaction wherein you are having, say, for example, AB and it splits into A plus B. This is called as decomposition. What is a combination reaction? Combination reaction is exactly opposite of decomposition reaction. A and B combined to form what? AB. A and B combined to form what? AB. So this is the decomposition reaction. What was the color change? Color change was from white to yellow. Yellow when hot, white when cold. That is zinc oxide. Washing soda, which is white in color, is giving you sodium carbonate. That is also white in color. And the water vapor, which is evolved, that is also colorless. So there is no color change over here. But what we can do is we can test cobalt chloride. Like we have seen this earlier. If you want to we want to confirm that water vapor is being released. So test this. We have done this earlier. Cobalt chloride plus water will give us pink color. So that's how we can identify that water vapor which is released is pink in color. Okay. Then copper sulfate dot 5H2O. This will be blue in color. Yeah. This will be what? Blue in color. Okay, and this blue colored thing is going to turn colorless or white. When it is going to turn white? After heating, after all the water is lost. See, it is the blue color is because of the water with it. After the water is lost, it will become what? Colorless. Okay, then zinc nitrate is white again, and after heating it will convert into zinc oxide, which is yellow when hot, white when cold, that we know already. Copper nitrate is blue in color, but copper oxide we already know that it is black in color. Earlier we have marked as well. So blue is converting into black. And again nitrogen dioxide will be a reddish brown vapors. And oxygen is a colorless gas. But if you still want to understand this, bring an agarbatti close to it, glowing splinter bolte, agarbatti close to this, and it will rekindle it into flames. Okay, it will rekindle a glowing splinter. Okay, then lead nitrate, it's we having lead nitrate white in color, it will convert it into litharge, which is yellow in color, that is PbO. PbO is lead oxide, but another name for PbO is litharge. Again, it's giving you NO2. NO2 is reddish brown in color, and oxygen, as I've told you, yeah, oxygen, as I've told you, can rekindle a glowing splinter. So this is the way we can identify. Then ammonium chloride, if you heat this, is going to give you ammonia plus HCl. It's going to give you what? Ammonia plus HCl. Okay, and ammonia is will do what? Ammonia, this will be dense white fumes. Okay, dense white fumes are white in color, and both of them will be colorless. This will turn blue litmus red, sorry, red litmus blue, and this will turn blue litmus red. Okay, then we are having iodine. Iodine solid, which is violet in color. Okay, will convert into if you heat that, it will convert into vapors, because it's a sublimable solid, it's completely sublime. Okay, then we are having ammonium dichromate. Ammonium dichromate, which is orange in color, and if you heat it, it will decompose to chromic oxide, which is green in color. So orange to green is the conversion out here. Okay, orange to green is the conversion out here. So the residue is green in color, and nitrogen gas is also evolved over here. Then you can see over here, we are having a metal. Okay, metal carbonate and a sulfide. So if you add sulfuric acid to these, what's going to happen? When you add sulfuric acid to a metal, hydrogen gas will be evolved. Hydrogen gas burns with a pop sound. Okay, and hydrogen gas is also able to extinguish glowing splinter, and hydrogen gas is also neutral to litmus test. Okay, then another one is carbonate. Carbonate, when you treat it with H2SO4, it will release carbon dioxide. Carbon dioxide can turn lime water milky. Okay, then with sulfide, if you treat H2SO4, you'll get H2S with a rotonic smell. Okay, so this is what your practical chemistry is all about, right? Is there anything else? Applications of flame test, this you have to, I'll send you a video, or maybe I'll try to show it to you right here. Just a second. I have something called the flame test. Let me just find it. Yeah, found it. So let me share my screen. Can you see the screen? Hello?
Yes.
Can you see the screen?
Yes, sir.
Yeah. Have a look at this. Yeah. Can you see this? Lithium is burning with a lilac flame, lilac kind of flame. Sodium burns with a, not lilac exactly, reddish kind of flame, that is lithium. Strontium and potassium will burn with kind of lilac flame. Sodium burns with a golden yellow flame, and copper burns with a green flame. So now do you understand how your firecrackers develop color? So your firecrackers are developing color because they are using this. Okay, these kind of metals, and therefore they develop what? Color. Are you able to see this? And this is also the flame test, right? To test sodium, what do? I use a flame test. I put sodium in flame, and I see what color is obtained to confirm that yes, this metal is sodium. So this is a way we can test. Did you understand this? This is a way we can test what? Metals. We can test metals. Okay, and calcium will give you brick red. Calcium will give you brick red in flame test. Okay, remember that. Calcium brick red, sodium golden yellow, lithium red, potassium, lilac. Need to remember this. This is also there. Hard water and soft water is there for you. Hello, is this there for you? Hard water and soft water. Hello, I'm asking you something.
Yes, sir.
Yeah, okay, fine. You can do that point on your own. Hard water, soft water, not a big deal, right? You've done in your lower classes also in 8th standard. So, did you understand this? Practical chemistry, it's very easy. Did you understand it?
Yes, sir.
Yeah.
Yes, sir.
So, I'll also drop in the recording in case you have missed out on something. And children who are not here, you can ask them to watch the recording. Okay, so a very good evening and thank you to all of you.
Good evening and thank you, sir.
Yeah,
Bye,
good
sir.
evening
Have
and
a
thank
nice
you.
day, sir. Bye, sir.
Yeah, good evening and thank you.
Bye, sir.